Imagine a universe where time ticks the same for all, regardless of their speed. What if time dilation didn't occur at high speeds? This is a thought-provoking question, isn't it? And it's one that challenges our understanding of the very fabric of the cosmos. You see, time dilation is a fundamental principle nestled within Albert Einstein's theory of relativity. It's the idea that time can pass at different rates for observers in different frames of reference, particularly those moving at high speeds relative to each other. This concept has been proven through numerous experiments and plays a critical role in technologies we use every day, such as GPS. But let's embark on a journey of imagination and ask ourselves, what if this cornerstone of modern physics simply didn't exist? The implications are profound. A universe without time dilation would look vastly different from the one we inhabit. It would mean a complete overhaul of our understanding of space and time. Let's delve deeper into this fascinating hypothetical scenario. Without time dilation, the very fabric of our understanding of space-time would unravel. Let's dive into this a bit further. Albert Einstein's equations of special relativity, which have been verified with painstaking precision, hinge on the phenomenon of time dilation. If time dilation didn't occur at high speeds, these equations would be incorrect. Imagine for a moment a cosmos where light doesn't have a speed limit. Sounds a bit wild, doesn't it? But that's exactly what we'd be facing in a universe sans time dilation. The speed of light, currently understood to be a constant, and the ultimate speed limit in the universe could potentially be exceeded. Furthermore, the principle of relativity itself would be undermined. This principle hinges on the idea that the laws of physics are the same for all observers, regardless of their relative motion. It's a fundamental tenet that ensures the universality of physical laws. But without time dilation, this principle would become shaky. Consider two observers, one stationary and the other moving at a high speed. Currently, thanks to time dilation, they would observe different passage of time. But in a universe without time dilation, they would observe the same passage of time regardless of their relative speeds. This would challenge the core principle of relativity, suggesting that the laws of physics are not the same for all observers. In essence, the absence of time dilation would necessitate a radical rethink of our understanding of space-time and the laws that govern it. It would be akin to pulling a thread from a finely woven tapestry, causing the entire fabric to come undone. The absence of time dilation would invalidate the principle of relativity, shaking the pillars of modern physics. The technological implications of a world without time dilation would be profound. Now imagine for a moment a world where your GPS system starts giving you inaccurate directions. Sounds like a nightmare, doesn't it? This is precisely what could happen if time dilation were to suddenly disappear. You see, our GPS satellites orbiting the Earth rely heavily on the principles of time dilation to provide us with precise positioning data. These satellites carry extremely accurate atomic clocks that are set to tick along with the time on Earth. But because they're in a higher gravitational field and moving at high speeds relative to us, they experience time dilation. The onboard software compensates for this effect, ensuring that the time signal sent to your GPS device is accurate. Without time dilation, these compensations would be unnecessary, and the time signal sent by the satellites would be off. This could lead to errors in the location data provided by your GPS. Imagine trying to navigate to your favorite coffee shop, but your GPS keeps insisting you're in the middle of a lake. Not ideal, right? But the implications go beyond just making your daily commutes a little more adventurous. We're talking about potential disruption in navigation systems on a global scale. This could affect everything from aviation to maritime travel. Pilots and sailors rely on accurate GPS data for course plotting and collision avoidance. Without reliable data, the safety and efficiency of these modes of transportation could be seriously compromised. And it's not just about getting from point A to point B. Many scientific and military operations also depend on precise GPS data. Whether it's tracking wildlife migration, monitoring climate change, or guiding a missile to its target, the absence of time dilation could throw a wrench in the works. So, as you can see, the effects of a world without time dilation would ripple through our technology-dependent lives, causing widespread disruption. The very fabric of our technological infrastructure, which we often take for granted, is intricately linked to this strange and counterintuitive principle of physics. Without time dilation, we could be lost in more ways than one. In a world without time dilation, scientists would have to return to the drawing board. Imagine this for a moment. The absence of time dilation would trigger a re-evaluation of the very foundations of physics. Theories and models painstakingly constructed over decades, even centuries on the framework of relativity, would suddenly be rendered obsolete. This is not just a minor adjustment. It's like learning that the Earth isn't round after all, or that gravity doesn't exist. The absence of time dilation would be a colossal shift in our understanding of the universe, demanding a comprehensive rethink of everything we thought we knew about space and time. But it's not all doom and gloom. Yes, it would be a daunting task, a monumental challenge, but it's also a tantalizing prospect. After all, science thrives on the unknown. It's driven by the urge to explore, to uncover, to understand. The non-existence of time dilation could be a roadblock, yes, but it could also be a catalyst. It could spark a new revolution in physics, leading to the discovery of new principles that govern the universe. Just as Newton's laws paved the way for Einstein's theory of relativity, this hypothetical scenario could usher in a new era of scientific thought. It's a daunting prospect, but also an exhilarating one. It's a reminder that science is a constantly evolving field, always pushing the boundaries, always questioning, always exploring. So while the idea of a world without time dilation may seem unsettling, it's also a reminder of the beauty of science. It's a testament to our insatiable curiosity, our relentless pursuit of knowledge, our unyielding desire to understand the world around us. And who knows? Without time dilation, we might be on the brink of a new understanding of the universe. The absence of time dilation would also have significant cultural implications. Imagine a world where time is absolute, not relative, a concept that aligns more closely with our intuitive understanding. This shift would reverberate through our shared cultural consciousness, influencing the stories we tell, the films we make, and the art we create. Consider the vast array of literature, films, and art inspired by the strange and counterintuitive implications of time dilation. Novels that toy with the elasticity of time, films that depict interstellar travel across the ages, and artworks that encapsulate the relativity of our existence, all would be fundamentally different or perhaps non-existent. Our cultural landscape is, in part, a reflection of our understanding of the natural world. The philosophical implications of a universe without time dilation would echo through our collective consciousness. We would grapple with a different set of scientific truths, ones that might resonate more closely with our everyday experiences of time. In this alternate reality, our cultural narratives might be starkly different, as they would be grounded in a different understanding of the universe. Without time dilation, our cultural landscape may have been shaped by different scientific truths. A universe without time dilation would look vastly different from the one we know. Without this cornerstone of modern physics, our understanding of space-time would unravel, potentially shattering the cosmic speed limit set by the speed of light. Technologies we take for granted, like GPS, would stumble and falter, causing disruptions in navigation systems worldwide. The absence of time dilation would prompt a massive rethink in scientific theories and models, possibly ushering in a new revolution in physics. On a cultural level, our perception of time, often reflected in literature, film, and art, would align more closely with our intuitive understanding, potentially reshaping our philosophical and cultural landscapes. The interconnectedness of time and space, as described by relativity, has influenced not just the cosmos at large, but also the minutiae of our daily lives.